Hi, welcome to an Arduino tutorial from Robojax. In this video I'm going to show you how you can control a 16-channel relay module using Arduino, using only 6 wires with this multiplexing chip CD74HC4067. You can get the code for this by clicking at the link which is below the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. There will be an application or situation that you need to control one of the 16-channel relay using your Arduino Nano, Arduino Uno, or Mini, which has limited number of pins, and let's say you are using other digital pins for other purpose. So this program that I have written will help you using the multiplexing to control only one relay at a time. That's why I said you can control one relay, and you need this module, or maybe you can get just the chip. This is the CH74HC4067. This is a multiplexer and it has binary input. It needs 4 wires for this and 2 other wires. One is for enable, one is for the signal to connect it to this, and then you just select in terms of binary. The code that I have written, it just sends it to this module, which is in my hand, this one, and then it will select one of the 16 channel and it will turn on the relay for you. So if you're thinking that you can use multiple relay, this code is not for that because you are using multiplexing. I have a separate video explaining this, how this can be used directly without this chip connected to Arduino. The link will be provided, and in that video I have mentioned all the aspects and the specification of this. I'm not going to spend time on that. So if you want to know more about this, please watch that video, because this video is not about explaining all the features of this. Let me explain now the module. This module has 16 relays, 8 on this side and 8 on the other side. These are 5 volts relay rated at 10 ampere, and the rating is 10 ampere for DC voltage for 120 and also for 220. Here we have the pin headers. Here it says 5 volts, 5 volts. This is regulated 5 volts. And here we have 2 ground slide, 5 volts from external powerful source, and there is also a regulator. You connect this to the power. You don't have to connect anything here, because once you connect it, it goes to the regulator. From regulator, the 5 volts will appear here. K1, K2 they call it, called contact 1, relay 1, whatever, I don't know. So whatever they had in mind. So D1 up to, these are the LEDs for each relay. When the relay is turned on, this will turn on, so that's 8. And then here 9 up to 16 on this side, up to 16. Each relay has 3 contacts. These 2 pins are normally connected or normally closed, as you can see by drawing. And this is open, as you can see here, it shows open. Once this relay is energized, these 2 will be connected. So you will connect your load here if you want, when the relay is turned on, to be connected. This module is utilizing this chip, the CD74HC4067, sorry, and this is a multiplexer, and it has 16 channel, as you can see, from 0 to 15. So these are the output connected to this chip. And on this side we have ground, will be connected to ground, and VCC connected to 5 volts. Enable, one of the pin that you need to put it high to enable. And also then we have S0, S1, S2 and S3. These are the 4 pin of binary, because we have 16 bits for that, so you need to have 4 wires to control that. And then the last pin is a signal. And you will get this module from eBay. I'm going to provide you the link. This can be either sold as red or blue. Both of these are the same. You will have to solder these pin headers on this side and on the other side. I've just soldered it already. Now I have connected the power here from my power supply. It's around 5.5 volts, and I want to test this module before connecting it to Arduino. So connect a DuPont wire female to female, connect it to the ground, and then we will connect it through these channels 1, 2, 3, 4, all of those, and we will see if this goes on. So we will do this test to eliminate any errors later on when we connect it to Arduino. And the first thing, this is channel 1, 2, 3, 4, 5, 6, 7, 8, and then it goes 9 up to 16 here. I'm connecting it to 1 here now. The first one is on. Now let's go to the 2, 3, 4, 5, 6, 7, 8. This row is done. Now here 9, 10, 11, 12, 13, 14, we are here, 15, and then 16. You will connect 5 volts here, but there is a controller here that controls the output voltage. I've explained it in a separate video. You can connect up to 12 volts. That will supply converted to 5 volts, because if you connect 5 volts, still it will reduce it. It might not be enough for this. For that reason, I have fixed this. This has a model defect. As you can see, this wire is here. I have separate video explaining how to fix this. So please watch that video if you want to learn about it. Otherwise, just connect 5 volts here, and hopefully this will work. If it doesn't, watch my video and fix this. Now on this side, I've connected 16 female to female wire, DuPont wire, and on this side 8 female to male. This side goes to Arduino, and this side goes to the relay module. Here from the multiplexer, all the wires that start from 0 to 15, from here from 0 to 15, are connected to the wires, to the pin 1, 2, 3, 4 up to 15. The first pin is VCC or 5 volt. It's empty, not used, and then the last 2 pins are ground. So these first 2 pins are 5 volts on this side, and on this side they are not used. And here one of them is connected as a ground to Arduino. And for the module, I'm providing external 5 volt supply, because these relays need a lot of current, and to not overload Arduino, I suggest that you use external power. And then the ground pin here is connected to my Arduino ground in here, or you can connect it any other ground that you find. For this side, if you hold these tiny wires from this side, I've connected from this side to pin 765432. Okay, so it goes from pin 7 to pin 2, and here directly, as you can see them, these 6 pins from green to black, and then the 2 last pin here, this is a VCC, which have been connected to the VCC of Arduino in here, and the other one is a ground connected to the ground. And one thing not to forget, from this ground, I've put here an orange. If you do not connect this, the system will not turn on. So this has been connected to the ground of Arduino in here, this orange. Now let me explain the code. You don't need any library because I've written it. It's just a simple code. And we add, as a constant, we define sig or signal pin. This is exactly what is labeled on the module, or SIG. And then EN, that's enable pin, pin 7. And then we have an array with 4 elements. And these are the 4 pins, 3, 4, 5, and 6 that I'm using on Arduino. You can change them accordingly, but I've arranged them such. And if you look here at these pins, it says SIG, and then this is S3, S2, S1, S0, and then enable. Because they are in this order, I arrange them here from SIG, pin 2, and then 3, 4, 5, 6. That's is 0, is 3, is 2, is 1, and is 0. After 6, enable, that's pin 7. So you will just connect them from here to Arduino in the same order. You can change it as you wish. And then this delay loop, the loop delay is a amount of time that these code will be sent to the relay. For example, right now relay number 5 is turning on, and relay 6 and 7, and we are printing it on the screen. But for real world application, you don't need to run all the relay or loop, but if you want to do so, just change it accordingly. And these are the multiplexing value table for S0 to S4. With the 4 wires, we can represent it as binary of 0 and 1, and these can represent with 4 bits. With 4 bits, you can go up to 16 different positions from 0 to 15. And this is now, if I stop it, when we send 0, that is sent this value each separately, and then for 1 we are sending this one. The difference here is that I've reversed it so it can be read easily. I've sent this, for example, for 1 this way, and as you can see in computer, least significant bits is sent first, and then accordingly then this will be the most significant bit. But for human reading, we always put the least significant on the right. Least is on the right. So for reading purpose, I've just flipped them so you can read it in actual binary. This is 1, 2, 3. This is readable, and here it will be hard. So we are sending this value for each channel up to 15. The setup, and you don't need to change this. And for the setup, we have to define our 4 pins as an output, and I put a loop instead of copying and pasting this 4 times. I just put it 1 time, and with this loop, which goes from 0 to 3 less than 4, and I changes 1, 2, 3, and here we put pin 3, and when I is 2, it goes to pin 4, pin 5, pin 6 as an output. And also we are setting the same pin, all of them high, because the relay that I'm using is low trigger. And this line, we define the sig pin as output, the signal pin as an output, and also we set the value as a low. Because our relay module is low trigger, we need to send low to turn the relay on, so we are setting low. If your relay trigger module is high, just set this high. Every time we send a signal, instead of 0, we are sending 1 to turn it on. This relay will be turned on with low, so that's why I'm putting here low. And then for enable pin, in order to enable, we set it to low. First we set the EN pin as output, and then we set it to low. And then this 9600 baud is the baud rate of the serial monitor, and this must match the number that is here, otherwise you will not be able to read the text. Then inside the loop, the action starts, and for the test purpose, I'm running this for loop, which goes from 0 to 15, 1 less than 16, and it just checks each relay 1 by 1. As I mentioned, you don't need to run it in real world application unless this is some kind of game or something that you want to display. But for real world application, you just need to run this one. So this I becomes 0, 1, 2, 3 up to 15, and every time it changes, we put I here. This is as if I type 1, 2, 3 up to 15, and we are sending into this function which I've written. I'm going to explain it next, and then we wait for this loop delay time in terms of millisecond, which was defined above, and right now it's 1 second. Every 1 second, this is causing the delay, and it runs. And then we print this on the screen to make sure to know that 1/5 cycle is completed. All relay have been controlled once. And let me explain this, what it does. When we pass 0 or 1 or 2 up to 15, it comes here, and that I becomes relay channel. And here we use that one as a number, and control pin, we take the value from 0, 1, 2, and 3, which are these control pin. We have defined 0 is this one, 1, 2, 3. So we say go and get pin 0, which is 3, and then this will go to pin, this is as if we type 4 and then 5 and 6, and then we say max table, and we put this value here. When we put this value, it becomes whatever this number. If this is 1, it goes to 1, and 2 or 3, and the 0, 1 and 2 and 3 will pick the value from here. When we say 0, it will pick the value from here, 1 will pick from here, 2 or 3. So we are getting the value and then sending the pin at that value. Either, for example, let me stop it. If we, let's say if we are picking channel 10, it will be 10 and then it will be 0. So we are getting the first value, and then 1 will be the second, and this will be the third, and this one will be the fourth one. From channel 10, if I look at the 10, these are the values that I have flipped them and display them here. So this value will be sent to the multiplexer, which will control to pin 10, and we also display it on the screen. And here is what I have done. Instead of 0, 1, 2 and 3, I put 3, 2, 1 and 0. Now for your application, you will control your relay like that. So you will not use this loop. Let me comment this out. You will do it like this. Let's say you want to control relay number 6, it will be 5. So you just put 5, that will be relay number 6. If you want to control relay number 14, just put 13, and it will turn on the relay, which I'm going to show you next. Now, before doing anything, I'm going to demonstrate it on LEDs. These are the pin from Arduino that comes here. This will be connected to this module. So let's quickly understand it, that what happens if I open the serial monitor. Now look, it's all 0, it shows 0. When it's 1, so that's one binary. Now let me reset it. So 0, 0 means all of them are 0. 1 is this one, 2 only this will be on, 3 this and this, and 4 this only, and 5 with this one. So this is the binary value that we have to send. As you can see now, this is 8, that's 9, that's 10 now, 11, 12, 8 and 4 is 12, plus 1, 13, plus 2. So that is all 15. Now let me demonstrate it, and the code is running, and the serial monitor is getting this value from the Arduino, and the power has not been connected. I'm connecting the power now. As you can see, it goes to pin 9, 10, 11 and up to 15, and it will come back to 0. Right now it is set to 1 second. I will comment this out, and here I've copied and pasted, and if I put 11, it will turn on the relay number 12. It's now waiting to run 16 times before disabling it. So let me disable it. So as you can see, there is no delay, and continuously it just runs for relay number 12. And if I want to run relay number 8, I will type 7. As you can see, it just goes like that. And if you want to add the same delay here, you can do so. For your application, you might have something like this. Let's say if the temperature increases, let's say if you have a variable temp, temperature less than 80 degrees, let's say a liquid cool down, and you want to control turn a fan on. If it's less than 80 degrees and the fan is connected to relay number 8, just type control relay 8, and if the temperature is less than 80, you just turn it on. Or the other way, whatever you want to do with this. This is your line to control any relay you want. But keep in mind that you can control only one relay at a time, not multiple. If you try to do multiple, it will not work. Let me change the time now to 200 milliseconds and connect this. Let's see how fast we can go. Now it's 100. Now it's 100. 100 milliseconds. I'm going now 50. Very fast responding. Now it's 30. Still working. Let's make it 10. And that is very fast. Thank you for watching. This was how to use the 16 channel relay using multiplexer and only 6 wires. Please thumb up the video, and also if you have comment or question, please post it. I'll try to answer and reply. If you subscribe, you can get updates of my upcoming videos. And that is very fast.